All right, word. So, Jason Hillstrom here and Alexander Roberts, and I'm talking here with Jason about. We're gonna start with the Drake equation, and just the a general gist of it. I think is that it is an equation that is trying to figure out the statistical chances of life occurring in the universe or galaxy or wherever applicable to that. And you can apply different statistics like what are the odds of life arising, what are the odds of different types of planets that are habitable to life developing within solar system evolution and galactical evolution, as well as just like every statistic you can think about, like the chances of life being wiped out before it becomes smart, chances of life wiping itself out when it's smart through self-annihilation, whatever. Jason, do you have anything to add to that? Is that a good generalization?
I guess in a broad idea, I would say the Drake equation is the optimist's idea on extraterrestrial life, looking to it as a positive that there is extraterrestrial life, and we're just trying to show that how much is out there with the Drake equation, and it does take into account all of those factors as far as how smart life is and how many planets could be there and how many of these planets could have the potential for life. And it starts off with its numbers in the positive. For being that we have one planet, Earth, habitable and showing signs of life, two of the variables there are one, so it can't be zero or negative. So the Drake equation is basically the optimistic view of the possibility of extraterrestrial life.
Yeah, and I also would add to that. I think that the statistics of it that you're saying that it has to be a positive, even with the most pessimistic of numbers put into this equation. And you're trying to be really pessimistic about like life developing and saying like 1 in a billion or 1 in whatever, and life being wiped out, and have really pessimistic statistics put into this equation with the amount of stars there are, whether you're looking at a galaxy or bigger, that the same thing happens where it's a very positive view, that there always seems to be a lot of.
Well, the number is 20.
The number is 20 with the highly pessimistic
our
view?
galaxy.
Okay.
Just our galaxy.
With what kind? Is that the pessimistic numbers or the non?
That's the minimum number. The minimum number is 20 possible life forms in just our galaxy. The maximum number is going to be 50 million.
50
in our galaxy.
At any one point? At any one point, this is the case?
That's the numbers.
Okay. Okay. So boom. So yes, it is very positive in the sense so there's 20. It's like Star Wars. There's like 20, including us. So 19 other populations that are intelligent life forms that are to the point of communicating. Is that part of it as well? I feel like that's part of it. They can communicate with each other. We've reached the point at which we can communicate with each other. What are we talking about here with intelligent life? What is intelligent life? Is it just radios, or is this, like what are we talking about with this 20 or 50 million? What is the definition to make it part of that 20? Is it fire? Or is
No, it's not. I wouldn't say it's fire. I wouldn't say that it's even the ability to communicate verbally. It's the ability to communicate externally beyond your own planet.
Okay, so like radio, boom. Is it conscious though? Because I feel like in the 1930s we beaming stuff out. Hitler, right? Wasn't it in 1933 the Olympics, German Olympics? We beamed out our first radio telescope stuff outwards. Wasn't it? I feel like we beamed something out at that point. I feel like that was always the irony, that the first things they would see of humanity. But if we're generating radio stuff, isn't that going out there naturally as well? I feel like all of this is happening.
Right. Well, So that would be communication. That's what we're saying communication is. In 1959 are the numbers that I'm seeing, or that is the date that I'm seeing, that we had the ability to receive signals, and we have been sending out signals in the wavelength of 21 centimeters, which is supposed to be the same wavelength that the atom hydrogen emits, which would be the most common element in the universe.
Yeah. So it's all logically driven.
Since the early 60s.
Okay.
Early 60s. And let's see, 1961. There was where this whole theory came from.
So I would say then it's that at that point. That's where this 20 is, or 50 million, is the point at which it's like the SETI program. That's when that's all developed, correct? And then
yeah, SETI, exactly.
Yeah, okay. So
Extraterrestrial intelligence.
Say it again. I was talking.
Search for extraterrestrial intelligence. That's where Drake, Dr. Frank Drake.
Yeah, working with Carl, with good old Carl Sagan. Yeah, I know. Oh, yeah. Yeah, Carl Sagan, Drake, they were all heavily connected. And Carl Sagan, for people that don't know him, is amazing, first of all. But second of all, did the Cosmos program, the one that Neil deGrasse Tyson didn't do, I feel, as well. The original one was Carl Sagan, and he was one of the first astrobiologists. Astrobiologists? I think that's the correct term. Biology of astronomy and cosmology. So, okay, word. So, we're getting it. So, the SETI program, the 60s, where we're aware of this possibility, is where the Drake equation comes from, and I would consider that probably that's where those 20 is. You got to be at that point or way better, which is I think a great shifting point to talking about the Fermi paradox is.
Well, let's just break down the Drake equation real quick and explain all of the variables of it.
Okay, word.
So, the way it's written is N being the number of societies, or not societies, intelligent life forms, or civilizations, whatever you want to call it, however you want to name it. And then we have R asterisk, I don't know the proper terminology for these subtexts, but that's the average rate of star formation.
Oh.
So it goes N equals R subtext asterisk multiplied by F sub T.
Which I feel like most people are gonna. What you're telling right now, they're just like, what is all this stuff? It's like deep calculus, right? This is deep
calculus. It's just a simple equation. It's all these variables multiplied by each other.
Oh, okay.
So where it came up from was Drake trying to figure out a way to calculate possible intelligent life before the SETI program convened, which they named the Order of the Dolphin, because
the Order of the Dolphin.
One of the scientists was working on dolphin communication at the time. So this theory came up, or this equation came up, and the main variables that Drake put into it were N being the number of civilizations, R being rate of star formation, which in the minimum is 1 star per year, even though nowadays NASA scientists...
There's going to be way more than that.
There's 7 stars per year formed. Okay, well, saying the minimums.
Okay, okay.
F sub P is the fraction of those stars that would have planets. N sub E is the number of planets that can potentially start life. And then F sub I, or F sub L, would be that they could actually develop life. And then going on further is intelligent life. And then intelligent life that can develop technology, release, and that would be detectable in space. That's what they mean by communication, is having a technology that would be detectable in space.
And then, is there any more of that? Is there an annihilation? Okay.
What?
Never mind. No, keep going.
The final variable is how long these societies or civilizations can sustain a detectable signal in space.
Oh.
Of the intelligence speed.
And so so that could be you could infer from that they're killing themselves, they're running out of resources, they freaking have a super war, Star Wars war, and they just cease to exist. So oh my god, that's a very poetic way, I feel. The way, say it again, what's the last one? The amount of time, right? What is it?
The amount of time that can sustain a detectable signal.
Right, that's a very, I feel like that's a very elegant way of being like, the amount of time before your species dies. Game over. So, okay, so that's the whole Drake equation broken down, and even with the most pessimistic views, you're at, boom, 20 civilizations out in the galaxy. And then there's a kajillion galaxies. There's got to be what? With
80 billion.
80 billion galaxies. Oh my god. And then I've started watching stuff about space expanding and stuff. That's only the visible universe, and there could be stuff because of the inflation things going on that are expanding fast. Yeah, so that are expanding faster than the light can travel to us. And everyone's like, whoa, that doesn't make any sense because it's traveling faster than the speed of light. But it's actually space is expanding cumulatively more than light can travel through it, so that we will never see that light from those really distant galaxies, because the space in between us and them is getting bigger, faster than the light can travel through it. Boom! So, okay. So, yeah, there is probably a lot more. But 80 billion, rough estimate. 13...
That's just of what we can see right now.
Right, and it's what? Approximately 13.8 billion light years across is the universe. And so, okay. So, that's pretty good, you know? Like, in Star Wars, how many species you think there were in Star Wars? There had to have been, like, what, 50? 1,500?
Who knows? I don't know.
Either way, so rough estimate, we're at least like 20 species worst case scenario, 50 million best case scenario. This is the melting pot galaxy here, and everyone's having that. So there is 80 billion times possibly 50 million could be the amount of intelligent species in the known universe, in the visible universe.
That's the very, very, very positive view of it.
Yeah, yep. But in the other way, 80 billion, we can do the math on the pessimistic, right? 80 billion times 20 million, 20 is freaking, what, 60 billion? 160 billion?
It'd be 1.6 trillion.
It's 1.6 trillion? There we go. 80 billion times 2. 80 billion times 2 and add a 0. I'm not the math person. This is Jason's moment here.
No, I don't know. It's 1.16, lots of zeros.
Okay, boom, lots of zeros.
1.6 trillion.
So, like, in the most pessimistic,
1.6 trillion.
1.6 trillion. So you killed it. Man, that's good. 80 billion times 20, 1.6 trillion. I like it. So in the most pessimistic views, that's how many at this moment. Think of how that's weird. That's weird to think about. That at this very moment, there are 1.6 trillion other yous out there that could possibly be thinking about this, because there's like one of us. This is a very humanistic, egocentric viewpoint, but there's got to be, like, in these solar systems where these other things reside, someone that's philosophically contemplating its own place in the universe, and that there's 1.6 trillion of those occurrences happening at this exact moment in the most pessimistic of viewpoints. That is pretty remarkable. Pretty freaking... Whoo! That's pretty cool. Okay.
Let's jump onto the flip side of that. The most recognized critique of the Drake equation.
Yes, true.
The Fermi paradox, which is with all that possibility, with those huge numbers and huge potential, how come with as much time and effort that we've put into trying to find intelligent life, we have come up dry. We've never found any evidence.
Fermi was Russian, wasn't he? Was he Russian? I feel like he was Russian.
Give me 1 second to confirm this. He is. Okay.
I don't know. My theory is being because the Russians are being very pessimistic about life. That's my theory. But that's
Enrico Fermi, so he's Italian.
Yeah.
He was an Italian physicist.
Okay, so I stand corrected. It was the Italians. I don't know. I feel
He created the world's first nuclear reactor.
Okay, props. Then word to him. And I think it's a valid. I think there's okay. So the Fermi paradox, broken down in general terms, is where's all the stuff? Where is if the Drake equation is correct? And we have like I was just getting all on my high horse a second ago, getting all excited philosophically. There's 1.6 trillion other life forms out there. Where's all the stuff of these 1.6 trillion life forms, or 20 if we're talking specifically about the Milky Way galaxy? Where's all the stuff? Where's all their stuff? And we've produced quite a bit. We've sent the Voyager, both Voyagers. Did we make both Voyagers?
Kepler.
Yeah, well, like, at least in terms of, like, out of the solar system, we made a bunch of junk in the solar system for sure. Like, the moon's got a bunch of junk. We have a, like, sphere of garbage around Earth.
Well, I'm talking about, deep space, that look out into space. I mean...
Yeah, Kepler looks out into space, but objects that we've sent out of the solar system is pretty limited. I think it's 2, right? It's Voyagers, and maybe the ones before that, the Viking, is it the Viking missions? That, I don't even know if they did. But there's some objects, and I think one of the Voyagers is the fastest traveling man-made object, and that's way out there. I think at least past the Kuiper Belt.
Voyager 1's the only one.
Okay, that made it out, and the rest
successfully left the solar system.
Solar, quote unquote, but I still think it's technically in the solar system because I still think it hasn't reached the like Oort cloud and stuff because I hear that's like 2 light years away. That I don't think it's made it all the way. But regardless, back to the Fermi paradox. Where's all the stuff? That's the paradox of the Drake equation. Is you have all these people, but there's no stuff. There's no evidence of them. There's no monoliths or radio signals or anything. It could be very superficial. It could be very concrete, but there's no evidence at all. I don't know. What do you feel about this? What do you feel, Jason?
Well, there's a lot of theories that come up that try to explain that, and that would be, as far as referring back to all the variables, that say intelligent life doesn't last very long, that we could have a society that existed before us, or existed even here on Earth. Well, on Earth we have plenty of evidence, but even in our own
right.
galaxy that's near to us that would have died off because of the 2 main causes of having a civilization die off would be either a temporary thing like a nuclear winter or a permanent thing, which would be celestial decay where the star dies.
I think, or just natural or personal, like natural or within, that like the space can kill you, whether it's what you're talking about, like permanent things like the star dying, resources running out, things like the core solidifying and then you don't have a magnetic field protecting you and then your atmosphere blows away, or the sun heating up to the point where your oceans become too hot or the air becomes too hot. And then I think
with that, most of the stars that we have around are red dwarfs, which put off too much X-ray energy for any planets within the habitable region to maintain an atmosphere. And as far as the cores solidifying, that would be a long shot. I mean, they even found evidence on Pluto, the planet that's no longer a planet, still have an active core. There's
and an atmosphere to a certain degree, a very thin one, but I get that. I think also though I've heard alternate theories about red dwarfs where they can be extreme. They might be the super habitable places. I've read about the X-ray, but I've also heard that they burn a lot longer. So there's a higher chance for statistical chance if there is a planet within like the green zone to develop because there's longer for it to develop. There's like a longer golden chance or time period, as well as that they if you get at least I was reading it was Scientific America, and they were talking about super like bigger planets that the plant material would have to be darker because of the different type of light emitted from they're calling them K dwarfs and D dwarfs, I think they were. So maybe it's not red, maybe we're talking about two specific different types of stars, but I think at least talking with the Drake, I think the biggest thing as an argument to that is we haven't found any shit or any stuff because of we haven't gone anywhere, you know? It's like walking outside of your front door and looking around and you don't see any cactuses, and then you're just like, okay, there's no cactuses, like there's nothing here. That I think it's and I think humans have done it consistently through the ages, is we act like we're the center of shit, that like everything's gonna revolve around us, whether it's Earth and sun's revolving around Earth or beyond that. With this whole, it's a very egocentric thought process, and I think the same thing is going on here with the Drake equation. And maybe he's just playing devil's advocate. I don't know the dude, but at least with the theory itself, it doesn't seem to hold a lot of credibility with me or a lot of weight with me, just for the mere fact that we haven't gotten anywhere. And so the only thing I can collect from that is either all civilizations do that and the Drake equation's right and we're just going to blow ourselves up soon because we're all idiots, or we're going to have famine. And every civilization in the history of civilizations do that, which I find it hard to believe. Like, there's got to be one smart kid in the batch. There might be a bunch of runts, but there's got to be at least one species that's like, hey, we can figure this out before climate change destroys us, or before we press a button and blow ourselves up. So I think that's one of it, and then I don't know. It's really hard to believe. I just really think it is.
That covers a few of the main contradictory points of the Fermi paradox. We haven't existed long enough. We haven't gone far enough. It's too expensive to spread physically. The intelligent civilizations are too far apart. I mean, moving forward, just to say how far we've gone into space physically. We've only been to our own moon.
Right? We've done probes. That could
like
be...
You said,
oh,
man.
man.
To the mailbox of the galaxy, like walking out of our house, which would be Earth.
Truly.
To the mailbox. And that's... Even though we can see far beyond that, we can't go... We can still only see across the street as far as being able to tell what's there.
And our speed, the speed and stuff is another major talking point towards the Fermi is, and I think the same thing with what you're talking about with getting just to the moon and everything else is just how truly big space is and how fast you really need to go to get anywhere. I think is a major obstacle that humanity or any species faces.
Unless you make galaxies at the speeds we can travel now, it would take 1 million years travel across our little galaxy. Our galaxy's not even that big. Right,
and what is it, like 300,000 light years across? So it's traveling at the maximum speeds, it still would take 300,000 years. Humanity, like what? The age of Christ 2,000 years ago? It puts it in perspective in the sense of even at the fastest speeds that are quote-unquote physically impossible, within relativistic like physics, like Einsteinian thought processes, that it would still take 300,000 years just to get across the galaxy. And then the gaps...
100,000 light years big. So
100,000. Okay, 100. See, I thought it was 3. Okay. 100,000. Even then, 100,000 years. 100,000 years. And humanity has been in a space age for 70. Like, oh God. Like, yeah, I think that's one of those those points to the Fermi paradox, where it's like a little kid that's really arrogant and thinks he's right about everything, but he doesn't have a clue what he's talking about, and he's never actually like lived at all. Like he hasn't been on his own or paid his own bills. That I think that's kind of what the Fermi paradox is right now. That the Drake equation is taking into account mathematics and a lot of other things that seem very fair and logical. And the Drake equation seems to be playing like almost a devil's advocate type view. And so it's either like
Fermi paradox.
Yeah, that it is either extremely pessimistic and depressing, and humanity and all the other civilizations are destroying themselves, or
Well, it also says that some of these societies may not want to be detected. They're here undetected, or they're here unacknowledged. We have yet to see them. And there's that possibility, too, that for these other societies, if they're there, it would be dangerous to communicate.
Yeah, and Hawking has came out with that, saying we should just listen instead of broadcasting outwards, just in case there's like predatorial species versus non-predatory.
That's another theory too. If you go back into game theory, if somebody's going to do that, if that's what we're going to do, that's possible that that's what everybody else is going to do.
I honestly think we're fearful of everything. I think that's honestly, again, another great example of human pushed, like this philosophy that's being pushed by humanity, that we are very warring. We do this within our own planet. And so we're like really fearful. That I think the irony of that, at least with humanity, is that the thing we're fearing is actually us. That we are that alien that is the dick that's going to go try to take everything over. That I think that is another psyche, that fear is being pushed by humanity and is like that egocentric thought process that I think is that drove the Earth as the center of the universe. That I think the same thing's happening there at a deeper level, that humans and this idea that there's aliens out there that are trying to colonize and destroy everything. I think ironically that we are putting that out there. We're projecting that image onto the universe and these other species.
Well, that's human psychology.
Yeah. Okay. So like we're talking about moving through space, and there is a major talking point that you were interested in about Mars, and probably one of the greater examples of us trying to get past the mailbox, as you called it, of the moon. So boom, what's up with this this Orion project? What's going on with this?
Well, the Orion Spacecraft.
Okay, excuse me, my bad.
Right, the Orion project is what you spoke about, the nuclear propulsion project, as far as blowing up nuclear bombs, using that energy to propel us to space. That program was unfortunately canceled, and then the Constellation program was a big program that NASA was working on, that Barack Obama in 2010, which under the advice of several analysts, they had canceled due to going over budget, being behind in their due dates. Either way, the only survivor of that program, the Constellation program, was the Orion Spacecraft, which was renamed the Multi-Purpose Crew Vehicle, and that is to replace the Space Shuttle in the future. That's what we're going to use to go to and from space in the future. And it's still, even though we've spent millions of dollars, years of research, it's still very much in its infancy. There's a lot of things that still need to be developed to make travel to Mars possible. And even though Mars is our next door neighbor, it would take us 9 months to get there. We need the Orion spacecraft to leave Earth's atmosphere. We still have to create a deep space habitat so that the astronauts can survive the 9-month trip to Mars orbit. And then I have not done an intense amount of research, but I have found nothing to describe how we're going to land on Mars
Like little balloon bubbles, like the red planet. I don't know. I just think that sitting in a pop can with 6 people, 1 people, whatever,
Four people's what it would hold.
that would be intense.
For 9 months, you would go insane. I mean,
Whew, I've heard. Have you heard anything about women? That the man versus women mix. What do you think about that?
Man versus.
All female staff of so you said there's 4 people on this, all women, all men, or mixed. What do you go with? You're the NASA planner. Boom.
It would have to be mixed.
Why mixed? What's up with this?
What's that?
Why mixed? Why are you doing mixed? Why?
Well, there's different parts about the human psyche that males handle better or are more adept in, and then there's different parts that females are better in, and it just creates a better balance.
Okay.
I mean, I'm sure humans could.
Yeah, I get that. I would agree with that. I would agree with that. The only thing is, I've seen weird research. I do think that I agree with you in the sense of men and women. I think they would try to get it in at some point, and I think that NASA or whoever is funding this would be stupid to try to stop it. But with that said, there have been NASA and through the International Space Station, there have been studies going on about the human body in space. And you were talking about this with even just the physical constraints of getting to Mars. Just with that exception, there is a horrible amount of other physical threats that happen. And one of the major ones that they're starting to see develop through this testing is inexplicably, they don't know why yet, but men, for whatever reason, can have eye issues develop where their eyes become worse. Their eyesight inexplicably becomes worse, and they don't know why it is, and it's not reversible. What's up?
Everything about being in space causes the human body to atrophy.
Well, yeah, these are NASA scientists. They're taking that into account, but they're saying that these male human these specimens that they're testing essentially out in space, like lab rats, are having eyesight that is decreasing over time in space, and they can't give a specific cause of it, and it cannot be reversed. So that once their eyesight goes bad, it stays bad. And it is not happening, oddly enough, within women for whatever reason, and they don't know what's going on. So I know that's going on, and so that's why I was just at least with your questionnaire thing. I'm like, oh man, I would knowing that. Would you go with an all women thing if you had an eyesight thing issue occurring randomly with men, and you don't know what's causing it, and it doesn't happen within the women?
Any astronaut would understand that risk.
Yeah, but not their risk. If they go blind or they can't see shit, they can't complete their mission, So it's a question of mission ability.
Well, we're going to go totally to something way more primal. Let's talk about football players and them knowing about concussions and them possibly dying in older age. You ask any football player, that being a big issue now, you ask these college players, knowing now that if you go play football, would you still do it? Or even younger professionals that have retired, knowing now that in the next 10 years you may face significant emotional issues, unexplained mental issues.
Oh no! See, I completely agree. I completely agree with what you're saying, but we're talking about in the short term this happens. It's not long term. So we're talking about that they can be only up in space for a couple months and their eyesight will go bad. That it's
like space director. Would it be what am I looking for? Would it be a problem? It's a small word. Would it risk the mission if men were on it? Yes,
and I think it would, at least with what these initial findings are suggesting. Maybe there's other weird curveballs as well, though. Like what you're saying with bone density and being able to retain that. I think what I've heard is that women do it equally with men, but the curveball for women is they have a higher statistical chance for whatever reason of developing cancer, and that's obviously like a huge issue. If you're traveling to freaking Mars with the solar winds and the radiation that the sun is discharging,
Well, I mean,
that
it's
could be a
like
big
we are
issue.
in our infancy in the whole project. There's going to be some risk involved.
Yeah.
We can't calculate all the variables. We don't know what it's like. There's been one man that stayed in space for a year. He stayed at the International Space Station for a whole year, and he's come back.
He was the twin, right? He has a twin brother. They're doing like relative. Okay, yeah, for sure.
And the twin brother that stayed on Earth, and I don't know any of the results of the study, but they're figuring out some stuff, and just like there's 80 billion stars, or excuse me, 80 billion galaxies with innumerable amount of stars, there's only 7 billion people on the planet, which is a small number now, but still everybody's going to be different, and it's hard to put in guaranteed results. So I would say as that just has to be some of the calculated risk that you take.
Yeah, and also I at least top of my head, the economically speaking, and no way, PBS Space Time, I'm pretty sure I heard this as economically speaking, women eat less than men, so it might be economically better to send women just because of the mass and energy it takes to move all of their food and waste they produce.
Well,
and oxygen, water.
Because of the cockpit size of the new fighter jets, women are being recruited heavier to be
really. That's interesting. That's cool. That's dope. That's really cool. Okay, word. Well then, so we're trying to. Is there any numbers? You said it's in its infancy. Is there any projection of when they hope to reach Mars? Oh, hell no. I know SpaceX is trying to get a rover or something, or some sort of probe by 2017, so it'll be the first private company to land on another planet, I think. By 2017, I don't know if that's optimistic or not. I don't know how they're doing.
So they want to go, I guess 2040 was what I'd heard before, now that I'm thinking about it, but when I'm looking at my numbers here, it says they want to send a Orion space mission into lunar orbit by 2026.
Okay.
So late 2025.
And you said they don't have a clue what's going on with, like, okay, we can get them around the planet, but how are we going to get a human being on the planet? They don't know what they're doing for that?
I haven't heard anything about that.
So, okay. Man, right? Oh, man. I don't know. It's like Mars, where they shoot a little pod that poofs up into a balloon and then it bounces all over the place. That sounds horrible. I don't understand why you couldn't do what you did with the moon. Isn't Mars gravitationally pretty equatable to the size of the moon? It obviously has an atmosphere, though, which the moon has none of. But I thought it was an extremely thin atmosphere, like 1%.
It's an atmosphere, but it's bigger than the moon. There's more gravity.
Okay. So more energy. Okay. So then, and then kind of pushing that further. So if we were humanity and we were going to get at least to the conventional limits, or maybe more like of a modern limit of the solar system, that I think that would be kind of a big stepping stone for us, that we can shoot things out of our solar system, but for humanity to get there, it would be to get outside of the solar system. And I think the limits of our solar system are kind of changing, and I think it's really cool that we're living in this day and age and witnessing all of this. But this new thing where we're starting to hear that maybe we're going to get our 9th planet back. We're going to get something going here. Do you know anything about this, Jason?
Well, there are several objects. First of all, there's a thing called the Kuiper Belt that's beyond Pluto. That's like a second asteroid belt, and there's supposedly, it's more complicated than just a second asteroid belt. There's a lot of large objects orbiting our sun on orbits that range from about 10,000 years and beyond.
10,000 years.
10,000-year orbit. Yep, those are the orbits that they're looking at.
That's crazy. That's longer than humanity. That's like caveman days. Nicole is playing Primal Far Cry right now. She's a caveman, 10,000 BC. That is that orbit. That's crazy. Continue. I'm sorry.
Okay. I'm just looking at. So basically, the way we haven't seen anything yet that we should confirm as Planet 9. It's all theoretical physics that are trying to understand gravities and orbital influence that are putting some of that influence into there being very large objects at that distance, and that's what they're naming Planet 9.
Yeah, like, long story short, Jason, very technical there. I love it. Long story short, there are objects that their orbits are weird. And the only way you can explain it mathematically and physically is through their Neptune, am I correct about this? Neptune Uranus sized body, like bigger than Earth obviously, but not a Jupiter Saturn type object.
No, they're big.
They're big, so they're thinking it's still big. They're thinking this thing is a beast. That this object with these orbits, these weird orbits, that mathematically speaking, the only way you can have these orbits happening is with some type of large body orbiting way the hell out there, way past the Kuiper Belt on what did I hear? It's like 15,000 year orbit. Is it 15,000 years?
10,000 year orbit's the minimum, and it's 5,000 times the mass of Pluto. Is what they're saying.
5,000 times the mass of Pluto, which Pluto is extremely small. So this, I don't. What do you like? How big compared to Neptune or Uranus or Earth? That's what I don't know. But either way, and I also have heard.
Give me a second.
Okay, while you're looking, I've also heard that in a statistical sense, that if this was random, that if it's just random, that it would be a 0.007% chance that would happen. That if it was in fact random, there's a 0.0007% chance that it's random. The other side of that, the 99.993% chance, is that there is in fact an object out there that is causing these unusual orbits from these Kuiper Belt objects that are similar they're compared to Pluto. They're Pluto-sized objects, like dwarf planets or Kuiper Belt objects or whatever you want to call. So they're bigger than asteroids, but they are.
Saying it's actually smaller than what I had thought. It's 10 times the Earth's mass.
So like Neptune.
Earth's mass.
It's like Neptune style.
Yeah.
Like an ice giant. Some sort of icy giant that's not big enough to become like a gaseous giant. So yeah, Neptune, Uranus type object. And the interesting thing I think is just so like, I don't know if there's any, I think it might be a coincidence, I don't know, but it's cool if it's not, is the idea that people throughout the ages, through the past century, have suggested the presence of this object. And that everyone just keeps dismissing it. And I think a lot of them are wrong. But it's ironic that then there is an object out there. There is, in fact, an object, if this is true, which seemingly, in a mathematical sense, the dude that is making all these bold claims is the exact same guy that started the demotion of Pluto. And he started finding objects that were bigger than Pluto, that were orbiting outside of Pluto's orbit, that were going further away from the sun. And so it's you either have 100 planets because you keep finding these objects, or you demote Pluto into a different category and it's not a planet. So, man.
Here's the exact definition of a planet.
Yes. Oh, yes. Absolutely.
The IAU definition of a full-fledged planet goes like this. A body that circles the sun without being some other object's satellite is large enough to be rounded by its own gravity, but not so big that it begins to undergo nuclear fusion, like a star, and has cleared its neighborhood of most other orbiting bodies. So the reason they're pulling out Pluto is because it essentially is, it's rounded. It does have an active molten core. It doesn't orbit another.
Possibly. It does. What is you
satellite.
saying? The molten core? What's going on with that?
Well, there's an ice volcano that they just recently saw.
Oh, okay. Okay. Continue.
On Pluto. Either way,
Continue.
there are too many objects around Pluto that are about its same size.
Yeah, Kuiper Belt objects. All these beasts.
Right. It hasn't cleared its neighborhood of other objects to
So what are they calling? What is
set
the
itself aside.
IU? The international? What is the what an acronym? Are you def?
IAU.
IAU International Union of Astronomy.
Hold on. International Astronomical Union.
IAU Union. Okay, so these guys are defining it. What do they call it? Is it a dwarf planet? What is the technical term? Dwarf planet. Okay, so that's the technical term. And so oh man. Okay, so this thing orbits every like 10,000 years, and that screws up my. There's a theory in the 90s from this guy that, like, at least in the viewpoints of like science, he's kind of an extremist. He's kind of eccentric. And he had this theory that every 25 million years or so, roughly 25 to 50 million years, there were major extinction points on the planet. And he thought that there was this planet, he called it was the planet X at the time, this planet 10, Roman numeral planet 10, was, because of its orbit, it was disturbing the outer Kuiper Belt and shooting in comets and whatnot, which I think comets originally are Oort cloud objects, but they shooting in asteroid rocky bodies into the inner solar system, and that was causing extinction periods that seemed to coincide, on like a very distinct variable, like a rough variable throughout the ages. And he was hypothesizing that it was because of this planet X at the time. It'd be very interesting if that was the case. It was 25 million years, so it doesn't seem to correspond with like you're saying 10,000 year orbit, 15,000 year orbit. So, I don't know. But it was an interesting point for sure.
Right.
So what's up? You got I think we call it good right there?
I would say that's plenty of time, yeah.